Hi guys, in this short video we're going to look at titration calculations. So in a titration, a solution of acid is reacted with a solution of alkali. So remember, a base is just something that dissolves in water to form an alkaline solution. And in a titration, you know the concentration, so the amount of solute per volume in one of the solutions, and you want to find out the concentration of the other solution. So the equation we want to use is this one, moles equals concentration times volume. And you need to know the units for each of these terms. The units of moles is just moles, so it can be abbreviated to MOL. Concentration is moles per decimeter cubed, so an amount per volume. And volume is in decimeters cubed. So you need to be aware of a conversion as well. You need to know that 1 centimeter cubed is equal to 1 mil, and to get from centimeters cubed or mils into decimeters cubed, we divide by 1,000. So there are 1,000 mils or 1,000 centimeters cubed in 1 decimeter cubed. This is equal to 1 litre. So now we're going to look at a worked example for how to find the concentration of a solution. So the question says a student performs a titration to find the concentration of some hydrochloric acid. The student finds that 21.25 centimeters cubed of HCl was required to neutralize 24 centimeters cubed of 0.1 moles per decimeter cubed sodium hydroxide. Now our first step in any question like this is to write out the balanced equation if it's not already given to us. So we're reacting hydrochloric acid with sodium hydroxide, so we write that plus that, which gives a salt, so the first bit of the alkali and the last bit of the acid joined together, plus water. Now notice we're given a volume and a concentration for the sodium hydroxide, so the next step is to work out moles of the sodium hydroxide, and we do concentration times volume. Our volume is in centimeters cubed. Remember, we need to convert that to decimeters cubed by dividing by 1,000, and that gives us our moles. Then we look at the balanced equation. Notice there are no big balancing numbers in front of the things in the equation, so we say that we've got a 1-to-1 ratio of acid to alkali, because we've got one lot of this and one lot of that. Therefore, that means the moles we've worked out of the alkali, the sodium hydroxide, we can assume must be equal to the moles of the acid. And then because of that, we can rearrange our equation, this one, to find concentration. So concentration of the acid, which is what we wanted to find out, is the moles of the acid, which is equal to the alkali in this case, because we've got a 1-to-1 ratio, divided by the volume of the acid. And here is the volume of the acid, 21.25, and we divide that by 1,000 to get it into decimeters cubed, and our answer comes out as 0.11 moles per decimeter cubed. I hope that was helpful. In the next video we'll do a similar worked example, but we'll look at how to deal with ratios, so balancing numbers in a chemical equation and what we do when we have those and how it affects the number of moles.